So this is our source image uh, to which I'm looking and making the CAD model, and this is the update on the robot. So first of all, I'll show you the internals of this robot. The This is the first revolute joint and this is the second revolute joint, which if I show you here is this part and this part. So this is our first base link that will rotate like this, and this is the second link which will have the motor that will make this arm rotate. So if I show you this, its movement, then we'll come to dimensions. So the first link rotates like this, and the second link will rotate like this onto this arm. Now let's come to the dimensions. The total height of this as of yet is, we'll go for the center distance or the normal distance, that is 10.84 inches, and if we come to its diameter, that is 5.31 inches. I've used the NEMA 34. This motor will be used in the base joints, this joint here and this joint. Now for the rest I'll be using NEMA 23 because of the loading issues. So that's all. This is the demonstration of the car blemish project. This is the whole look of the cube. Let's get started. These are the wipes that I'm removing right now, and now this is the plastic cube. So if we move it like this, we have here, first of all we have the battery, this is the magnet, battery, and then this separator. On top of that we have a tank, liquid tank, and here it is its stopper. Okay, so this hole will be used for inserting the thread that will be linked with this atomizer that will be making the steam. And here we will have some wires as well for the heating filament that's placed inside this. This will heat the liquid and this will produce the steam. So coming back towards up, now coming back to the other side, we have 4 LEDs over here. 1, 2, 3, 4. These are the indicator LEDs. These are the UVC LEDs on the PCB. This is a see-through plastic, acrylic plastic sheet that is used as a cover to stop the mist from hitting the PCB and damaging it. These are this mounting holes, screw, M2 screws for mounting the PCB. So these are the magnetic magnets, and these are their pockets. You see, these are magnets pockets. So this will be helping in the mounting system, magnetic mounting system of the cube onto the magnetic surface. Likewise, we have LEDs, UVC LEDs on the top surface as well. Let me show you, like so. See, so yeah, another thing, this is the dust sensor which must stay away at the distance of 3 mm from the wipe in order to measure the dust. And here we have a USB-C female port for charging the device. Now closing mechanism, let's see the closing mechanism. This is a snap fit closing mechanism. Bring the cube down and this will go inside, and once it's through all, it will latch back up. So that's the snap fit mechanism for closing the queue. Let's bring back the wipes, and likewise we have our plastic cube car blemish project ready. So this is the complete look of this design. We have the gearbox here. We have 5 gears and a reverse. 1, 2, 3, 4, 5. These move in H. Sorry. 1, 2. It will come back. 3, 4, and then 5. Now you see that I've added 6 limit switches here. You see 1, 2, 3, 4, 5, 6. This will indicate that when the limit switch is pressed by this lever of the gear like that, this will generate a signal that will either reduce the sensitivity of this accelerator or increase the sensitivity. So how will you notice the increase or decrease? That you will be feeling that you are pushing it harder than the previous time you pushed it, or it's a bit soft this time. You see, so as we move from the first to second gear, the sensitivity on this accelerator it reduces, right? Now from second to the third, let me show you. Let me demonstrate here. Let's say we are in the neutral, right? This was the first, now we're in the second. From the second we go to third, like that. Now the sensitivity in this accelerator has reduced significantly, and this is the brake and the clutch, right? So these are spring loaded, so their sensitivity does not change as commonly seen in a manual car. So the signal that will be generated here will be transmitted over here wirelessly. So these two boxes are not connected through wires, these are separate boxes. So yeah, that's the design. For the sensitivity over here, we'll be using electromagnet which will be enclosed in this cylinder, and for the force action we'll be using a permanent magnet that is a neodymium magnet, which will be which will be enclosed over here. I'll show you. Sorry, complete assembly. Yeah, over here. It's in this housing. You see, we have a disc here. We'll have a neodymium magnet over here, and it will be working with a repulsive force with this electromagnet and a permanent magnet. These down below are the rubber padding, so that the box don't slide away when you're doing the exercise. So yeah, that's the design. Thank you.
Hey, hope you're doing great. So this is the update regarding screen-free learning device. So in the previous video you have seen, we have integrated the NFC module and the DF mini player with the ESP32 one by one. So today we integrated both with the ESP32, and let me show the demonstration for you. Wait a minute, I'll start the test again.
is 2 minus 1?
So it is asking what is 2 minus 1. We know that the 2 minus 1 is 1. Let me insert 1.
Good answer.
So here you may see the green LED on and it replied with the good answer.
What is 1 plus 1?
It wait for a short time, then ask another question. Now it is asking the second question, which is what is 1 plus 1. So we know that the answer is 2. Let me insert 2.
Good answer.
So it replied good answer, and after
What
a
is 1 plus
short
2?
it is asking 1 plus 2. What is 1 plus 2? So we know that the 1 plus 2 is 3. So here I have the card with the 3 on it. Let me insert the wrong one with the 2. So let us put inside. Please close it. So let me insert 2.
Wrong. Please try again.
So it replied with the wrong and try again, and meanwhile
What is 1
the
plus
red
2?
LED on, and it asks again what is 2 plus 1. Let me insert 3.
Good answer.
It replied with the good answer, and after a
What
short
is 2
time
plus 2?
ask another question, which is what is 2 plus 2. Let me insert 2 plus 2, which is 4. Let me insert. Oh.
Good answer.
So
What is 2 plus 3?
what is 2 plus 3? We know that the 2 plus 3 is 5. Let us insert 5.
Good answer.
So yeah, that's the update so far. Hope you like it. Thank you. Hey, hope you're doing good. So this is about the project where we have to control the pumps using water level. So for that I'm using the same module as yours. So here you may see the module. So here you may see that I have also labeled the wires as S1, S2, S3, S4 and S5 and S6, which is same as your configuration that you have provided here. So let me start the demonstration for you. So let us put all of them into the water. So when all of the wires are dipped into the water, nothing will happen to the bulb 1 and the bulb 2. Here you may see that both the bulbs are off. So when we got S1 out, where is S1? So here it is. So when we got S1 out, nothing will happen to the bulb 1. When we got S2 out, the bulb 1 glows. So let's move to the other module, which is when we remove S4 from the water. Here is S4. When we remove S4, nothing will happen. Here you may see that the bulb A continues and the bulb 2 is off. So when we remove S5, the bulb 2 also glows. Bulb A continues and the bulb 2 also on. When we start filling again, S5 dipped into the water, nothing will happen to the both bulbs, bulb A and bulb B on. So when we dip S4, then the bulb 2 goes off and the bulb A continues. When we dip S2, nothing should have to happen. So here you may see that the bulb 1 stays on. So when we dip S1, the bulb A goes off. So that's the update. So what was the problem? In our previous case, we are using a single voltage supply to the module. So when we applied a single DC supply to both of the module, their voltage reference would be same. So in a result, the S4 from the module 2 makes a complete circuit with the module 1, which triggers the bulb A on by only dipping S2 instead of S1. So we changed the input supply to the different supplies to the both modules. As a result, their voltage reference now are different, and the S4 of S1, S2, S3, and S4, S5, S6 of other module, both modules have different voltage reference and different circuitry. So that's the update so far. Hope you like it. Thank you. Hey, hope you're doing good. So this is about the screen-free learning device. For that, after completing the schematic and a freezing diagram, now our objective is to implement this on breadboard. For this, I have bought several components from the market. So these are the components that I have bought today. So here you may see that the ESP32, the buck boost converter, and a DF mini player. This is the speaker, and this is the tags that we are going to use. So for today, I've also implemented, or you may say that I've integrated the NFC module with the ESP32. So let me start the demonstration for you. So for today I've trained this as it shows the question on the serial monitor, so we have to select accordingly the tags. So here you may see that the question is, what is 10 plus 2? So we know that the 10 plus 2 is 12. We have to scan 12. So after scanning 12, it says correct answer, and it replied with the another question, which is what is 1 plus 1. So we know that the 1 plus 1 is 2, so we scan 2. Here you may see that it replied with the correct answer and with another question, please scan the white color card. So we have to scan this card. So after scanning, it replied correct answer. And what is 1 plus 1? So if we scan the wrong one, like it is asking for 1 plus 1, which is 2, but I'm gonna scan the white card, so it replied with the wrong answer. So this is the update for today, so hope you like it. Hey, hope you're doing good. So this is about the screen-free learning device. So in the previous video you have seen that we integrated the NFC module with the ESP32. So for today I have tested the 5 different cards. I have added them to the NFC, and also here you may see that I added 3 different LEDs as per the Frederick diagram or the schematic. We know that the green is for the correct answer, red is for the wrong, and the blue is to show that the system is on and waiting for response. So here you may see that it shows please insert card with the number 2 at last. So we have to insert the card with the 2. So here you may see the green LED on, and it asks another question, please insert card with the number 3. So let us insert the number 3. So here you may see I have the card with the 3. So here you may see the green LED on. So it asks another question, which is please insert card with the number 4. If we attempt wrong, here you may see I'm gonna insert 3 while it is asking for 4. So the red LED turn on to demonstrate that it is wrong, and try again. So let us insert the card with the 4. So here I have the card with the 4. So let me insert. Here you may see that the green LED turns on. So that's the update so far. Hope you like it. Thank you.
Hey, hope you're doing good. So this is the design of the tissue dispenser right now. We have this tissue roll, a stepping motor. We have gears and disinfecting liquid tank. These are the atomizers, mist makers, and these are the rollers through which the tissue will be dispensed outwards. Yeah. So the first thing is that we can take this out, and using the help of a funnel we can add liquid into this, and this atomizer will spray disinfectant on the tissue that is being dispensed outwards. Uh, so first of all, let's see This is the core of the tissue, which will be on which the tissue will be placed. Uh, this is a pulley that will be holding the shaft of this core and motor together, and at the end of this we have a gear mechanism, gear chain. So this gear chain drives these rollers, right? So as the motor is rotating, these gears will also rotate, and these rubber paddings will push the paper forward. I've added bearings over here that will allow in a frictionless motion. And to take out the this tissue paper roll, and to put a new one in it, we have to just unscrew this shaft from the pulley right here through this hole. We'll take out the grub screw, and we'll push this backwards. We have enough space here. Push it backwards, and let me demonstrate it to you. Yeah, so like I said, we'll just unscrew the grub screw from here, from this position, and then we'll take out this like that, and then we'll just push it upwards. So it will come up from these hooks, and we can reinstall the new tissue on top of this core, and just like that we put it back inside these hooks and mesh the gear, place the teeth in the position, and screw from here. So it's a pretty easy install for this, and this mechanism is quite efficient, as we have many rubber paddings for the tissue to dispense. So yeah, that's the design for the tissue dispenser right now. So this is the Guardian band. This is the face of this is the look of this Guardian band, right? So first I'll show you the features. This is a threaded face, like that. We'll open it, we're closing it, we'll unscrew this like this, and it will open. Let me open it and then I'll continue. So yeah, so now this is unscrewed. We can see here we have a magnetic plate here, that is electromagnet energized by the electrical signal. Beneath this we have a buckle, and then we have the strap like that. So I'll show you the working of this. The buckle is designed as so that when we pull the strap this way, it tightens on its own without the electrical signal. You see that right now the buckle is sitting inside the strap and it's locked in its position. Let's say I try to push it this way backwards to loosen the diode, loosen this on the wrist, right? I push this way, you can see that this straight face will act as a barrier against this wall of the strap, and it won't allow to open unless pushed with shear force, right? Okay, so if I pull it this way, right, so you see that the face of the buckle is tangent here, or you can say that tapered, right? As this face hits the buckle will rise. This face will hit and the buckle will keep on rising until the strap is the buckle is out of this cut of the strap, and until it hits the other one, and then it will fall down. This is all happening under no electrical signal. Once to open it, To loosen it, we will have to energize this magnetic plate, this one, which will act as a puller. This is the magnetic piece of the buckle, which is here in a circular position to increase the surface area of contact with this magnetic plate and enhance the connectivity or the forces of attraction. This will rise up and the buckle will release the strap and you can push it backwards. Now loosen the electrical signal or kill the electrical signal and this will fall back in its position and this will lock. So we have this configuration. Sorry, yes. So this is our buckle and bring it back. This is our guardian band in the shape of a watch, and like that we have a guardian band.
Hello. So, Mr. Carl, I'm trying to draw over here right now. This was our designed module last time, not module, actually a controller. And now what you want is you want another type of sound module, let's say. So that would be like this in a rectangular shape. And you want 5 different types of designs. Just the designs would be different. So all of them can be, connected with this one, I think. This is what I have understood, right? So this is something, this circular thing is designed. This is already designed. And we have to design these 5 parts. Is that so? Is that what you're trying to say?
Hey, hope you're doing good. So this is the update regarding a pressure chamber project. So from the previous video you have seen that how we are applying different pressure to that chamber by applying different voltages through that supply. So now we move a step forward and we are doing the same thing using a screen. So currently I'm using a serial monitor to apply or to enter a number, to insert a number of required pressure, so which will update to a touch display later. So let me start the demonstration. So here you may see that if I need to maintain a 15 psi inside this chamber, I simply enter 1 5. So by pressing enter, it start maintaining a 15 psi inside that chamber. So from the display you may see that the 15 psi is generated inside the chamber, and also from the manual gauge, if it is visible, you may see that the 15 psi is generated inside that pressure chamber. Let me change the value. Let's move to a value, let's say 6. So when we move to lower value like 6 and pressing enter, the regulator release the air itself and maintain a 6 psi pressure inside the chamber. It shows 5.9, which is approximately 6 psi. So let's check for another value, like let's check for the 13. Yes, the 13 psi is generated inside that pressure chamber. So for a 20 psi, I simply enter 20. Regulator start generating 20 psi, and 20 psi is generated inside that chamber. Let me show you again that when the pressure is increased from the set value, the regulator itself release air from the chamber, and the pressure inside the chamber would be maintained at set value. So from this I'll set, say, 9 psi. When I press enter, 9 psi is value that is fixed for the pressure for the regulator to maintain 9 psi inside the chamber. It would release the pressure from the chamber to maintain 9 psi. So when I press enter, you may see from the regulator that it will release air automatically to maintain 9 psi. Yeah, it would release 9 psi is generated inside that chamber. So that is the update so far. Hope you like it. So thank you. सही है, हमारे पास फर्स्ट इंटरफेस आ जाता है जिसमें हम लोगों ने मोड सेलेक्ट करना होता है। तो अगर तो हम मैनुअल मोड पे जाते हैं तो ये आगे पास रिप्रेजेंट कर देता है कि मैनुअल मोड एक्टिव है, दैट्स इट। तो जैसे ही यहाँ से हम लोग बैक जाएंगे, बैक जाके अगर हम इसको ऑटोमेटिक पे सिलेक्ट करते हैं तो आगे हमें नंबर पैड दे देता है टू इंटर रिक्वायर्ड प्रेशर। लाइक अगर हमारी रिक्वायरमेंट 12 PSI है तो जैसे हम इंटर करेंगे तो जो हमारा टारगेट प्रेशर होगा वो 12 PSI हो जाएगा। तो मैं एक पंप ऑन कर लूँ। ऐसे पंप ऑन हो गया। जो अब हमारे पास प्रेशर मेंटेन होना चाहिए वो होना चाहिए 12 PSI। सही है, 12 PSI जनरेट हो गया हमारा इस चैम्बर के अंदर। और ये यहाँ से भी अगर कुछ नज़र आ रहा है तो ये 12 PSI। तो ये अगर मैं यहाँ से नहीं छोड़ूंगा तो जब तक मैं यहाँ पे कोई नई वैल्यू एंटर नहीं करूँगा तब तक 12 PSI ही रहेगा। लाइक अभी भी 12 PSI जनरेट होगा। तो जैसे मैं बैक जाऊँगा फिर भी 12 PSI ही रहेगा तब तक जब तक मैं नई वैल्यू नहीं एंटर कर देता। लाइक 15 PSI मैंने एंटर किया तो अब उसकी टारगेट जो PSI है अब चेंज हुई है और अब जाके वो 15 के ऊपर स्टेबल होगा। ऐसा 15 PSI जनरेट हो गया। तो बाकी इसके अंदर जो फिर हम लोग बैक जाएंगे, बैक जाने के बाद जब यहाँ से हम बैक जाएंगे फिर हमारा नॉर्मल मोड के ऊपर चला गया। अब हमारा ऑटो मोड से बाहर आ गया। अब जो 20 PSI जो जनरेट हुआ था वो कैंसिल हो जाएगा। तो सॉरी 15 PSI। तो ये इंटरफेस तैयार किया सर। प्रेशर अब इंटर करें 20 PSI। अगर अब हम इंटर करते हैं 15 PSI, ये ऑटोमेटिकली रेगुलेटर ने रिलीज़ किया है और 15 PSI। अभी अगर हम इंटर करते हैं 11 PSI, रेगुलेटर ने ऑटोमेटिकली रिलीज़ किया तो 11 PSI। इसी तरीके अगर हम लोग करते हैं 9 PSI के लिए 8.99.1 अप्रॉक्सीमेट 9 PSI। सही है, टोटल वीडियो है। जो हमारे पास इशू आ रहा था इसका PWM का ना, वो फिर एक एक वैल्यू लेके यानी कि डिफरेंट वैल्यूज़ लेके डिफरेंट उनकी जो रिस्पेक्टिव PWM और जो रिस्पेक्टिव उनकी जितनी भी हैं सारे उन पर ट्रेन किया फिर डिफरेंट। तो फिर अभी आके ये वैल्यू आई है, ये 220 हो गई। Hey, hope you're doing good. So this is about pressure chamber project. In this project our main objective is to maintain pressure inside that pressure chamber. So for this I'm using this regulator through which we are maintaining the pressure inside that chamber, and this is the pump through which I'm supplying or providing pressure. So here we may see that this is the display. This is the display through which I'm controlling 3 different ways, as our main objective includes 3 different ways, like manual mode, automatic mode and the profile mode. So in the manual mode it comes with the potentiometer. Here you may see that the potentiometer, it is used to control the regulator which control the pressure inside the pressure chamber. So as we control this knob, here you may see that the knob will control the pressure. So let's go back. to the main menu. Here you may see that the next mode is automatic. When we select automatic mode, here we come with the numpad, through which we enter the required pressure. Like if we required a 12 psi, we simply enter 1 and 2 and then press enter. After entering, our target psi is 12, and this microcontroller here, you may see that here we are using the Arduino Mega 2560. It will maintain 12 psi inside that pressure chamber. So after if we want to change the value, we simply go back and change the value to any other pressure like 20 psi or anything, as our range is 0 to 20 psi. If we enter a pressure greater than 20 psi, like if I enter 25 psi, it simply warn that our range is 0 to 20 psi, so please enter within range. So let's go back to our main menu, and here you may see that the third mode, which is profile. So in this mode we have to follow the pre-programmed graph. So for this I'm getting 1 to 7 different values from user. So you have to apply different 7 pressures for a 10-second interval. So for the first 10 seconds it will ask step 1 of 7. So for this I will enter 12 psi for first 10 seconds. For next 10 seconds I want to maintain 20 psi, and for the third 10 seconds I want to maintain again 12 psi. For the next I want to maintain 6 psi. For the next 2 seconds I want to maintain 15 psi. It's up to you, whichever value you want to maintain between 0 to 20 range. So let's enter 14 psi, and the last one is 19 psi. So here you may see that it plots the graph of all the values on the display, and it should follow the graph and the following points. Here you may see that the first 10 seconds with respect to time, the pressure increases up to 20 psi and then start decreasing up to next value whichever we enter. So let me start the demonstration for you. So here we come with the mode. So let me start. Wait a minute. So let me start the demonstration. For this I'm starting with the manual mode. So here you may see that the manual mode is activated, and our current, and from the regulator you may see that the current pressure inside the box is 0 psi. When we move this knob to the other end, here you may see that the regulator start maintaining pressure like 5 psi, 6 psi, and further if I move, it will increase the pressure 8 psi, 10 psi, 10 psi, 16 psi. So it increased the pressure up to 20 psi. So this is the final. Here you may see the 19.7, which is approximately 20 psi, and from the manual gauge you may also see that the pressure inside the chamber is 20 psi generated. Yeah, so this is the manual mode in which we are controlling or maintaining the pressure inside the chamber using this knob here. So let's move to another mode, which is automatic. Here you may see that the regulator itself releases the pressure inside the chamber to shift mode. So here we move to automatic mode. So here comes with the automatic mode. Let me check for the 12 psi. So now you may see that the regulator start maintaining 12 psi inside the chamber. Yes, you may see that the 12 psi is generated inside the chamber, and from the manual gauge, if it is visible, you may see that the 12 psi is generated. So let's check for another value like 20 psi. Let me enter 20 psi. So regulator start maintaining 20 psi. Here you may see that the 20 psi is generated inside the jumper. So from the manual gauge you may also see that 20 psi is generating. So let's move to the third mode, which is profile mode. Simply press back and press back again. As we come back to our menu mode, the pressure inside the jumper is 0 and all the pressure releases by regulator itself. So let's check for the third mode, which is profile mode. By simply pressing profile, we entered to a profile mode and a new numpad window will open. So here you have to enter 7 different pressures for 7 different intervals, and for each interval I have specified a 10-second delay. So it's up to you how many intervals time you want and how many intervals you want. So for the moment I'm using 7 interval and 10 second for each interval. So let me add 7 different values. So let me add 12 psi for first 10 second. For the next I would add 8 psi. For the next I'll add sorry, let me clear. So let me add 15 psi. Let me add 20. Let me add 5. Let me add 20 again. Let me add 20 again. So here you may see that the graph of the points that we have entered. So you can also see the 3 buttons on the display: a start button, a pause button and stop button. What will these buttons do? A start button simply start the system to follow the graph and start regulating the pressure inside the pressure chamber. The pause button will stop the system at the point where you press pause. So if you want to maintain or you want to hold at some point, so the stop button will again restart the same function. So let me start the demonstration for that. So by simply pressing start, you may see that the regulator start generating pressure. You may see that the 7.8 is generated, and from the graph you may see that the values are increasing by time: 13, 14, 15, 16, 17, 16 psi, 17 psi, so 18, and it increases up to 20 psi, and after 20 it start decreasing. You can also see from the graph here, from the 20 it start decreasing up to 5 psi, and after 5 it start increasing again up to 20 psi. Yeah, for 50 to 60 seconds, that are our last 10 seconds, we have to maintain 20 psi. We are maintaining 20 psi. So here you may see that 20 psi are generated, and as soon as the graph is completed, the system will turn back to its normal position, a menu position. So that's the update so far. Hope you like it. If you still have any question, do let us know. Thank you.
Hey, hope you're doing good. So this is our assignment. So you can see in the first terminal I am launching our gazebo environment. So you can see as I run the launch file for launching our gazebo environment, you can see our robot in our environment. Then we'll go to our second terminal, and then we'll launch our limo navigation.launch.py file, and it will open rviz. So you can see rviz is open, and here you can add topics like this. I am adding the laser scan topic, laser scan. Then I'll add the scan topic, and then we can see the scan the data from our laser. Then we have to give a 2D estimate, pose estimate. So I think our robot was here and pointing in this direction, and you can see this our laser scan has shifted a bit. We can add more topics like axis, camera, depth, etc. etc. Marker. So we can add as many topics as we want. Then we'll go, and then I'll run the porthole detection node. So this node is now running, and we can see the camera view of our robot and the portholes it is seeing through that view. Now we'll run our survey. So basically we are doing a random search with basic obstacle avoidance, so our robot does not hit the wall. It will search the environment for a minute. You can see the robot is searching, and these are the potholes, its camera view. So the robot is searching the environment and avoiding all the obstacles. The robot will search the environment for a minute. It will roam and try to avoid obstacles on both left, right, and its front. After this search, we will save our data, and we'll see how many potholes. So you can see the pothole number, it's P178179. So this is the pothole number. So after that we'll see we are taking images at 10 hertz, and after a minute we will see our results over here. Our robot will stop. I think it has stopped. So you can see the results. Total time are 60 second, pothole 467, and other assessment you can see over here. And we have saved the data to the pothole.csv file. We have saved the CSV data over here, and pothole.json file we have saved .json data over here. So yeah, that's pretty much all. Thank you.
This is our water alert system project. In this we will see that when we send alert from our transmitter side, it will be received on our receiver side, where relay will be triggered, and we will see our alert message on our application. This indicates that when I will short these two pins, then it will send an alert message. We can see on our app that water leak is detected, and when I remove this, we can see on our application that our leak is cleared. I basically use this because the rain sensor plate was not working well. I have to change the module. That's why I showed this, because I wanted to show clearly that our alert and our info messages are receiving correctly. Thank you. This is the working demonstration of our water alert system. On the transmitter side, we have the rain sensor. When we dip into the water, it detects the water leakage alert, and it sends signals to the LoRa module on the receiver side. and then the receiver side LoRa module triggers the relay which turns off the valve. And when we remove our rain sensor from the water, it sends signals of that water leakage is cleared. Then it again sends a relay another trigger signal which opens the valve. It triggers the relay, or solenoid valve closes and no air passing. It triggers relay again and it opens.
ਤੁਸੀਂ ਕਿੱਥੇ ਟੁਰੇ ਹੋ ਉਹ ਭਾਈਓ ਭਾਜੀ ਛੱਡ ਛੱਡ ਬੋਤਲਾਂ ਦੀ ਜਾਨ ਉਹ ਭਾਈਆ ਲੈ ਆਂਦੀਆਂ ਬੋਤਲਾਂ ਉਹ ਮੀਆਂ ਭਾਈਆ ਪਾਗਲਾਂ ਤੂੰ ਹੋ ਗਈ ਯਾਰ ਲੈ ਚਾਚਾ ਐਨਾ ਚ ਰਹਤਾ ਬਾਹਰ ਲੈ ਕੇ ਆਂਦਾ ਨਹੀਂ ਪਾਣੀ ਪੀਣ ਵਾਲਾ ਤੂੰ ਐਡਾ ਤੇ ਉਹ ਫਿਲਟਰ ਦਾ ਲਿਆਂਦਾ ਤੇਰੇ ਸਾਹਮਣੇ ਅਸੀਂ ਵਾਕਿਆ ਉਹ ਭਾਈ ਫਿਲਟਰ ਦਾ ਪਾਣੀ ਆ ਨਹੀਂ ਤੇਰੇ ਸਾਹਮਣੇ ਵਾਕਿਆ ਨਹੀਂ ਖੁਦਾ ਨਹੀਂ ਵਾਟਰ ਨੋਟ ਦੱਸ ਖਾਣ ਦੀ ਟਾਈਮ ਪਰ ਰੋਟੀਆਂ ਆਮੀਆਂ ਅਤੀਆਂ ਇੱਧਰ ਤੇ ਹਰਾਂ ਦੀਆਂ ਆਪਣੇ ਹਰਾਂ ਚਾਚੇ ਨੂੰ ਮਿਲਿਆ ਲੈ ਚਾਚਾ ਉੱਠ ਕੇ ਬਣਾ ਲਾ ਅਜੇ ਹੀ ਬੰਦ ਕਰ ਯਾ ਦੇਖ ਉਹ ਉੱਥੇ ਚੱਲੀ ਹੁਣ ਜਿੱਥੇ ਲਾ ਗਿਆ ਕੱਚੀ ਪੱਕੀ ਲੈ ਚਾਚਾ
अस्सलाम वालेकुम। ये मेरा दोस्त है असफंद यार, हम स्कूल में 6 क्लास से साथ हैं। ऐसे ही है नसफंद? कितने साल हो गए भला? 20 साल हो गए हैं, है ना? ऑलमोस्ट 20 हो गए हैं। और ये मेरा हालचाल पूछने आए हैं क्योंकि मेरी पाँव पे प्लस्तर हुआ हुआ है। स्पेशल चीज़ें लेके आए हैं हमारे लिए, ये इनकी मोहब्बत है, मिठाई लेके आए हैं। ये हमेशा हमारे दिल में रहेंगे असफंद। बड़ा अच्छा साथ है इनके साथ, बहुत साल हो गए हैं। ये दोस्ती असफंद कभी कम नहीं हुई, है ना? ऐसी है। और ये आपको टी ब्रेक कैसी लगी है? हमारी हिदमा, हमारी मेहमान नवाजी कैसी लगी है आपको? बंद करो, तुम नर्वस करते ये हम अभी एंटर होने लगे अपने गेस्ट रूम में। वाह क्या बात है। ये गेस्ट रूम है, टीवी लगा हुआ है, एसी लगा हुआ है। ये बेडरूम है, बेड है। ये पीछे अलमारियां, क्या बात। हैंगर लगे हुए हैं, वॉशरूम के लिए स्लीपर्स पड़े हुए हैं। ये सामने शीशा है, क्या बात है। ये पीछे वॉशरूम है, ये इनका कैफेटेरिया, पीछे इनका किचन है। ये हम जा रहे हैं अपने कैबिन में। ये एसी स्लीपर क्लास है, 2 बंदों का कैबिन है। ये वाली सीट खुल जाती है तो एक बंदा जब सोना होता है नीचे सो जाता है, एक बंदा ऊपर सो जाता है। तो जी सियालकोट में आज फिर धुंध पड़ गई है, ये आवाम फिर निकली हुई है। और आज की डेट है 25 दिसंबर 2025। तो अभी कम है, लेकिन जो पिछले 2-3 दिन के अगर मैं आपको डाटा बताऊं तो बड़ी धूप निकली हुई थी, मौसम चेंज हो गया हुआ था। बड़ी वाम यही कह रही थी कि ख़त्म हो गई है, सर्दी ख़त्म हो गई है ना, लेकिन देख लें आप, नेचर को कुछ और ही मंजूर होता है। तो ये धुंध पड़ गई है और अभी एक्सपेक्टेड ये है कि ये भी बढ़नी। चल मैं तुझे पूछता हूँ कि तू कहाँ आया हुआ है, कहाँ पे आए हुए हो भाई आप?
हम आए हुए हैं कैंट में।
अच्छा, और ये वी मॉल है,
ये भी
कैसा लगा आपको वी मॉल?
अच्छा है,
माहौल अच्छा है यहाँ
और
पे?
बहुत अच्छा है।
और क्या अच्छा है यहाँ पे, सब बताओ।
और क्या बताना है भाई?
वही बताओ जो आप देख रहे हो घंटे से।
और भी यहाँ जो है वो क्या कहते हैं पंजाबी में मेमिया।
हाँ वही ना, और हम यहाँ पे जमात करवाएं थोड़ी ना है। हम कोई तिलावत करते हैं यहाँ पे।